Hi everyone, my name is Carlos and I'm a software engineer at Zondax. We are a group of geek and curious people developing solutions for the blockchain industry since around 2018, and we have been working with the major chains and integrating the most innovative technologies. One of these is definitely Internet Computer, who has been a good partner of us. This year we wanted to expand this into the ecosystem and to develop something that can really add value to the community. So, as everyone knows, IC is one of the world's fastest general purpose blockchain. Web3 is being built on with a big and active community. And among its advantages, we would like to highlight its capability of literally allowing the developers to deploy anything on chain in the form of a smart contract. So today we're introducing our latest contribution, which is a C++ wrapper for the IC Rust agent, which we believe can help to bring more developers into IC. So in a simple way, in IC, developers can deploy their app either on their local machine or live on chain, and the agent is the way the developers and the users have to interact with the app. This means the agent should follow the app interface specifications, making it convenient to have as many languages available to create the agent. So, to facilitate future maintenance, we decided to build a wrapper for the IC Rust agent. We wrote a middle software layer that takes the Rust functions and exposes them to C, and then we use these C functions to build our C++ interface. We have chosen C++ because it's an efficient language that has many applications, and also this middle C layer that we have written can also be used later as a starting point for other wrappers, for example, Python. One of the main communities that can definitely benefit from our project is the gaming developers community. So all their C++ native projects can now have an IC interface running on chain, and then can use our C++ wrapper to interact with it. So now I'll just give you a quick walkthrough through our library and I'll show you some demo. So now let's do a quick walkthrough on our library. You can find it on Zondax GitHub. So we can start by looking into IC agent wrapper. This is the Rust part of the project. So here we have written some Rust code that help us to expose the IC Rust agent functions to C. So we have used cbindgen, which is a Rust tool, and in the end we are able to get on bindings.h, a C header file, we're able to get a C function, the signature of the Rust functions, but in C. Then we have the libagent-c. Here we have included the bindings.h created previously on IC agent wrapper, and also since some of the exposed functions are not too user-friendly, we have written some more C-friendly structures and functions to be used. So libagent-c, it's compiled as a static lib, and in case the user wants, you can also use this libagent-c as a C wrapper. It doesn't have all the functionalities that C++ wrapper has, but you can use it to interact with the agent in C. The last part is the libagent-c. So this is the final product. We have used functions from libagent-c and IC agent wrapper, and here you can find a complete C++ interface to use to interact with your app or your canister, to deal with ideal args and ideal values in a very simple way. So we have on examples a lot of examples to use the C wrapper. So how to interact with canisters, how to use the core functions, and on examples C++, we also have three use examples on how to interact with the canister using our C++ wrapper. Other tool that is really helpful, and it's included in our project, it's the C++ header generator. You can find it here on generate C++. So for users starting on IC, it might be difficult to understand and to deal with all with all the candid types. So this generate C++ basically allow you to take your candid file from your app or your canister and create C++ header file that you can use to call your canister services in a simple way and using only C++ native types, but I will show you later on the example. Also on the README you can find all the information you need, so regarding how to build and how to compile the library, how to use the generator, how to run the tests, because all of our core functions are covered with testing, and in the end a small example on how to include our library on your own project. And yeah, that's basically it. So let's go into a little demo. Yeah, so now let's do a quick code demo. So I've written some simple hello world example. So it's a canister, a simple canister that you can send a string. I'm sending Zondax, and we'll get the return hello Zondax. So basically we just need to clone our library inside your project. I've written a CMake file that will link my project to our libraries, so to the libagent CPB and to the libagent C. And then we can go inside our library just to build everything. So we go inside this build folders, CMake, to create the make files, make, and you'll have everything built, including the examples in case you want to try it out. So then the user would have a candid file for the canister. I have mine. It's called rust hello backend.did, but well, for the C++ user this is not really helpful, so we just know that we have a service called greet, and if we send a text we get a text, but this is not C++ types. So we can go inside our IC agent wrapper. You can drop your candid file inside, and then you can run your cargo run to generate your file, and the generator will create a folder here called source declarations, and inside you'll have your C++ header file. So as you can see, this is now greet. It's a C++ function that takes a string arg and returns a string also. And here we have the service class where we're going to put our agent, and then later we can use this service to get access to all the functions from our canister. So let's go into the code. Basically here just setting the principal and the identity of our canister and agent. We create the agent, and then we create our service with the agent that was previously created, and then it's very easy. So to get to interact with the greet service from the canister, we just have to do like service.greet with our arg, and we'll get our response. So the user can point out on the CMake of its project, can point out to the created header file. I just copied mine to my project include folder, so it's here, and then we just need to go out. I will compile my project, run make, I have my target, and then we just can run hello world, and we have hello Zondax.